Alright, you guys, this is going to be section 6.5 for Algebra 2, but it's the third part of this section. First thing, wanting you guys to sketch a graph of this. Well, it's the same graph as this that you guys know. It's a parabola, but it's been dropped 25 units. So this graph is sitting way down to 25 units down. Okay, with this point being 25 units down. So it just said sketch, so it's not intended to be very good. Not that my drawing on graphs is very good with this pen, but you get my point. Y is equal to, and it says factor it. You guys should recognize this. It's a difference of square pattern. Something squared minus something squared. So you square root both things, and one's a plus, one's a minus. Okay? Now, find the zeros of this. Well, there's a couple ways you could do it. One is, you've already factored it. You could set this thing equal to 0. Let y be 0. If you have something times something and it gives you 0, either one of the things has to be worth 0. So you could set the factors equal to 0. Those are your two zeros. Now, going and looking at the picture, actually what those things correspond to are your x-intercepts. So again, this is an example of where you use the factors to find your zeros, which are your x-intercepts. So the factors are connected to the zeros, which are the same thing as your x-intercepts. Okay. Now, another way that you guys could do this is, sure, when you set this thing equal to 0, I could add the 25 over because the middle term is missing. What do I mean by middle term? Say you had ax squared plus bx plus c. Because b is missing, this thing is missing, I can do what I'm doing here. If it was there, I couldn't do what I'm doing. Now square root both sides, plus or minus because of the variable. 5 is equal to x. Okay? But again, the factors are connected to the zeros, which are indeed your x-intercepts. Okay, this one, sketch a graph of it. I can't pull up the graphing calculator. Here it is. So I'm just going to pull this thing up here as if I sketched it. Okay. All right, factor this. Well, the leading coefficient is 1, which is nice because then they're both x's. Things that multiply to negative 12 but add to 1. So that must be plus 4 minus 3. Find the zeros. Well, I'm going to set those equal to 0. So why did it like that 4 and not like this 4? It bugs me. And x minus 3 equal to 0. So x is equal to negative 4, x is equal to 3. And look at the picture. Negative 4, 3. The factors are related to the x-intercepts, which are the same thing as the zeros. Okay? So if I ask you to find the zeros, you're really finding x-intercepts. If I'm asking you to factor it, you could look at the graph, see the zeros, and come up with the factors. Now notice, for ones as simple as this, when the leading coefficient is 1, aren't the zeros in the factors opposite? Well, why are they opposite? Because when you set the factors equal to 0 and solve it, to move this to the other side, I have to do its opposite. To move this to the other side, you have to do the opposite. Okay? Given the following factors, what are the zeros? Well, you just saw me do them. So subtract the 5. X is equal to 5. I do the opposite of this number to get it to the other side. So I'm doing its opposite to get it to the other side. So the opposite of that number moves it over. So x plus 7 is equal to 0 because I'm looking for the zeros So I'm setting it equal to 0. Now here's where it gets a little trickier. It's not the opposite of that number. Now watch what happens. 2x is equal to 3. Now you divide by 2. X is equal to 3 halves. This is in particular where I want you guys to pay attention. If I give you the 0, what are the factors? You can always start by writing x minus. And then fill the number in. So those go plus. Okay, so you got x plus 3. You got x plus 6. Oops. And x minus 12. Now when they're fractions, be a little careful. It is not x minus a negative 3/4 or x plus 3/4. Nope. Look and see where this came from back on this one. That 2 on the bottom was a coefficient in front of the variable. So this is really 4x plus 3. This would be 4x minus 3. So be careful when you have fractions. It's not going to be x minus 3/4. Okay? Sketch a graph of this. Now before I start, I told you that x-intercepts were the same as zeros. Now this I'm going to push that issue a little bit. I need to be a little bit careful when I say this. Okay? Because what I said was wrong, but it was wrong for a reason. And we'll get there. This graph is the same thing as the graph y is equal to x squared, which just goes right through the origin, but it's been lifted 25 units up. So that coordinate there is 0, 25. It's been pushed 25 units up. All right? Factor this. Well, when you guys had the difference of square pattern, it was x plus 5, x minus 5. This is a sum of squares. It turns out there isn't actually, it doesn't factor. If you guys did x plus 5, x plus 5, well, that would multiply out to this. It gives you the middle of 10x. This doesn't have it. This is unfactorable. Now, I showed you another way to find the 0 if you didn't have the factors, and that was setting this thing equal to 0. Subtract the 25, and you should see it right there why there's a problem factoring it. Because once you square root it, this has to come out as I. So plus or minus 5i is equal to x. Now that you know the zeros, what are the factors? Well, x minus 5i and x plus 5i. Now, where are your x-intercepts? There are none. When your zeros are imaginary, they are not x-intercepts. When your zeros are imaginary, they are not x-intercepts. X-intercepts equal zeros if, and it's a great big if, your 0 is real. When it's imaginary, it is not an x-intercept. Okay? When your 0 is imaginary, they are not x-intercepts. Okay. Factor this polynomial. Well, I'm telling you one of the numbers is 0. Makes a 0. This thing is a 0. So right away, you know that thing's a factor. Now, it's degree 3. To make this idea work, you have to believe that because it's degree 3, it'll break into 3 pieces. And because they're telling you 1, 0, they're telling you one of the factors. And if I divide that out, do you see how I'd have 2 left? And you guys know how to factor stuff when there's 2 left. So this is what you do. Divide the sucker out. 15, 16, negative 5, negative 6. Drop the 15, negative 15, 1, negative 1, negative 6, 6, 0. the remainder has to be 0 for this to work. Otherwise, it's not a factor because it wouldn't have divided it evenly. So you've got remainder, number, x squared. So now you have to factor 15x squared plus 1x minus 6. Now granted, this is a little bit of a pain because the numbers aren't perfect. They're nice. I'm going to go for 2 and 3 for the back to get the 6. The front, it's going to be 3 and 5, and the 3 isn't going to go here, the 3x, because that would be a 3 in common. If there's a 3 in common, you should be able to factor out a 3, but you can't. 3 doesn't factor out of it, so I know it's not going to be that. Okay, so 3x, 5x. Now, one's got to be plus, one's got to be minus because it's multiplying to negative 6. Now check the O and the I. Outside, minus 9x. Inside, 10x. I totally got lucky on the first try. So 1x. So this, or these, are the factors. Factor the polynomial given one of the zeros, which is a factor. You divide that factor out, and you're left with the polynomial so you can find those factors. Now, they could take you one step further and say, give me the zeros. So now that you have that, then you can go to subtract the 2 and then divide by 3. Okay? Given 1 0, find the remaining other zeros. Okay, again, this is a factor, x minus 3. Divide that out. 3. So 5 minus 15 minus 8, 24. Divide, or pull the 5 down. 15, 0, 0, negative 8, and then negative 24, so 0. So remainder, number, x squared. You're left with 5x squared minus 8 is equal to 0. It said find the remaining zeros. Because the middle is missing, like I did with you on a problem earlier, I'm going to add the 8. Divide by 5. I'm going to take the square root. I'm going to split the square root right away because I know I need to. Plus or minus the square root of 8. You guys know that's 2 squared roots of 2. Square root of 5. I know I need to rationalize it. And so I get 2 squared roots of 10 over 5. Oops, plus or minus. Okay, those would be the remaining 2 zeros. Because remember, the thing is degree 3. So I need 3 zeros. They told you one of them. The other 2 is plus 2 square roots of 10 over 5, I believe it was, and minus, whoops, 2 square roots of 10 over 5. Did I write that down right? Yep. Okay. I'm going to clear this to give me a little more room. One of the zeros is 5. 1, negative 9, 21, negative 5. Drop the 1. 5, negative 4. Okay. Crazy 4s. 20. Oops, negative 20. So that would be 1, 5, 0. Remainder, number, x squared. Again, your remainder has to be 0 for this to work. X squared minus 4x plus 1. Is it going to factor? No. There's nothing that it's going to multiply to 1 and add to 4. So, to find the remaining zeros, the one thing you guys are going to be left with then, the only other tool you have to find the zeros is the quadratic formula. B squared minus 4ac all over twice a. So, opposite of b, 4, plus or minus negative 4 squared minus 4 times a times c all over twice a would be 2. 16 minus 4. Ugh. 16 minus 4, there we go, all over 2. 4 plus or minus the square root of 12 all over 2 is 4 plus or minus 2 square roots of 3 all over 2. Now remember, when you guys go to reduce this, it has to reduce in both places. So it has to cancel there and there. So 2 plus or minus the square root of 3. Those are two answers. It's 2 plus the square root of 3 and 2 minus the square root of 3. You're welcome to write it like this. I'm just telling you, they told you one answer and you found 2 more for a total of 3. Okay? This one. You're given a graph and you're looking at these x-intercepts. You've got an x-intercept of 1, 2, 3, 4, 5, 6, 7. Looks like -7, -3, 2, 3, 4, 5, and 5. So the factors are going to be x plus 7. Remember, you do them opposite. X plus 3, x minus 2, and x plus 5. And if you were to multiply all those together, which isn't what we're up to right now, you would get this graph. I'm just letting you know that I'm just trying to tie this back into what we've been doing. Okay? So I believe that's the last screen. Yep. Thanks for